Hello, my name is Shamansir. Actually, it's a nickname. And what I'd like to present to you is the tool for Elm language, which is mostly just the same as IPython does for Python. So you may, as you see, evaluate expressions, for example, strings, or floats, or numbers, or chars, actually anything. It is not limited to basic values, of course, so you may actually render the results of the result of any function, say 5, 5. So you see, determine that and the result has the type of integer and the sum is 10. But it not ends even with these examples because it would be boring if it was. In April, I wrote a post about binary engineering Elm interface files, and the purpose of it was actually to extract the type of Elm expression, because Elm compiler or a parser or whatever, it has no reflection, and you can't easily determine the type of expression. So it required me digging into some files, and that stuff, that's another story. But what I told even in this post, that the Elm language is very fitting for different graphical stuff like three-dimensional, two-dimensional, visuals or something. The another thing that inspired me is picked 3D package for Racket language, which is like Scheme on steroids. And it has the REPL, which is read-eval print loop. And actually you may pass anything to this REPL, and it shows the nice small canvas with the object. Actually, I may even try to launch it. Oh, Dr. Racket. Because it's actually controllable. Fractal trees. It was something. Yeah, so it is able to run, and actually awesome. So in this small screen, you actually may drag the object. Of course, it uses all the graphical processor power, but anyway, you may enable lights, see the wireframe, I suppose it is, and different other stuff, or even zoom. But now I'm just zooming the vectors. So back to the IL. Actually, why not seeing the interesting example? Sorry, Dr. Record made everything small. I will quit it. So this is one of the examples from WebGL library, and it renders to something like this. Matrices are not shown for the moment, but you may observe the shape. Not by dragging currently, but by moving the mouse. This is the example shape. It's not perfect. It will be more perfect later. We'll get back to this example, but before I'd like to show you another feature of this IL tool. It is the controllable functions, or I don't know the best name. I haven't considered one for this. What it does, it actually sees that your function accepts an integer value, for example, which is emitted. So like a partial application. And so you may control it with some range input. So actually this cell corresponds to this variable, and the next cell to this one, and so on. So in this case, if we add 0 to 10, we get 10, of course, and if we add 100 to 10, we get 110. And here, by dragging the range sliders, we're getting the sum of values. It is not limited to integer values. You may control Boolean values, floating numbers, and so on. For example, this one calculates, this one calculates the sum of the length of the strings, of two strings, and this one concatenates full. Now it adds the length of the full string to what you type. This one concatenates two strings, so and so on. You're just required to emit an argument to the function. You may render HTML in documents as well. I haven't considered another example. Oh no, I have the SVG example, which is would be quite nice. So this is the clock example, just the default Elm clock example, and some SVG path rendered in a cell. Here, for the moment, we just pass 0 for time, but let's try not specifying the argument. Since the time is the type ls for a float value, we actually need to change change this to float to be able to control it. Yet it's not moving, but it is expected because the time should be in milliseconds and the range is from 0 to 100, as you have seen. So let's multiply the float value, and now we get moving clocks, which is, I think, quite awesome. Let's see if it works with WebGL. This is the rendered triangle, and we move it a little bit. So if we want to move it a little bit more, we may just multiply the input value by 10, for example, and pass it to the view function. Since this is an expression, it renders it as a cell. So here's what you get. You even may, okay, let's do this. I haven't tried it before. Let's try it now. Yeah. Okay, one of them was 0. So one is the speed and another one is acceleration. Looks like that. Okay. And of course the college library, which was developed by Evan, it probably was one of the first packages and all. It would be also quite interesting to debug it. So here we see a rectangle, which is done through square outline and a star. And we may control the size of the rectangle as well. And another nice example which is more monstrous, I would say. Here we pass more parameters to the star function, so we get actually this. We may control the number of corners of the shape with these two sliders and the rotation with another ones. So actually this star is just made of two triangles, which are, okay, yeah, sure. One is rotated this way somehow, and another one this way. Yep. But the main purpose of this tool is to actually serve like a smart REPL. Elm REPL for the moment is not very smart. But in this case, we may determine any value, including type aliases for records. Let's see what we have. These screens, I call it screens, are actually connected and merged into one file, so you may reference one function in another screen. But before you have to compile it, it says change it, so it's not compiled. So in this case, I hope we'll get the same foo here. And we did. It was quite tricky to extract maybes, but now it's possible. And just to demonstrate to you that controls work for everything. These are maybe just, maybe nothing values. These are result values, like the complex ones, alias applied, and this is the function which takes float and int and generates the maybe value with a tuple of these two. So probably that's it. Oh, sorry. Connected to a server. I will open it to public very soon. And as soon as I will get it working in your so you will be able to install it in your project and import your own modules. It is easy. All these modules are not included. I just have the sample package which installs just with normal Elm package flow, which installs everything you could need. So probably that's it. Thank you for your attention.